Okay, now we're going to be solving a rational inequality. Remember the graph of a rational function looks, here, that's going to be a little bit confusing. Usually when you have f of x is equal to 1 over x, the graph typically looks something like this. When it's a little bit more complex than just a constant over x, you have to be careful and probably put in a table of values to make sure you know where it's graphed. But the process of solving is very similar. You find your domain values, and this time the domain is going to be whatever zeroes out the numerator and the denominator. So the inverse for the denominator, the inverse of -7 is 7. For the numerator, the inverse of -1 is 1. So 7 is larger than 1. And for our values to work with, well, 0 is an easy number smaller than 1. I'll probably choose 5. That's an easy number. And then positive 10. And again, we're going to plug those into the function to determine if it's true. And because this is, well, I'll show you how you would write the domain and the interval notation in a minute. So when we plug 0 into here, 0 subtract 1 is -1. 0 subtract 7 is -7. -1 divided by -7 is positive 1/7, or a positive number. Is a positive number less than 0? False. When we plug 5, well, 5 subtract 1 is 4. 5 subtract 7 is -2. A positive divided by negative is a negative number. Is a negative number less than or equal to 0? True. So between the domain values of 1 and 7, it's going to be true that the values are going to be a smaller or a negative value. Okay? So that's what that true means. And now we're going to put 10 in there. Well, 10 subtract 1 is positive. 10 subtract 7 is positive. Is it true that a positive number is less than 0? Well, that would be false. So normally, because of that solid line, you'd get square brackets. But remember, when it's a rational equation or inequality, whatever zeroes out the denominator, so positive 7, at positive 7, there's a vertical asymptote. Well, you can't touch a vertical asymptote. So when we do our interval notation, the 1 gets the square bracket, but the 7 gets an open parentheses, even though there's a solid line. So look at what we have. This region between 0 and 7 is true. That's where all the values will be negative. So let's look at this graph again. Here we have between 1 and 7, and here is our x-axis. Oh, look it. Between 1 and 7, the values are negative. From -infinity up to 1, you're above the x-axis, and after 7, you're above the x-axis. So whether you graph it or whether you use the number line, both of those things are true. All right, that's it for this one.